Good day, boys. Good day, girls. How are you? Hope you're fine. Hope you're well. Hope you're not feeling too cold. So this afternoon, we carry on with our math lesson, and today we'll be looking at correlation. Yesterday we looked at regression, the least regression equation, and then today we'll be looking at correlation. Okay. So before I carry on again today, I'm Faru Abdullahi, and in statistics, we'll be looking at today correlation and regression. Okay, at the end of today's topic, we should understand and apply important statistical terms such as scattered points. Yesterday, we looked at scattered points, how to plot scattered points, and then today, we'll be looking at the correlation. We look at correlation, how two variables relate, how they correlate with another. Okay, and then we're looking at the strengths, different types of correlation. The strength of correlation, how strongly positive or negative one variable is in relation to another. Okay, so first of all, correlation. What do you mean correlation? We're saying the strength of a linear relationship between two variables in a scatter point depends on how close the variables, how close the data points are to the line of best fit. Yesterday we looked at scattered points, and then we're saying in the scattered points, so the points are not in a straight line. The points are not usually on a straight line. So what do? We need to get a line of best fit. We need to look at a line of best fit. And the line of best fit must be such that it must connect 2 or 3 points in a way that it's going to leave some points above the line and some below the line. So we're saying that is the line of best fit. And then we also explained yesterday that the line of best fit will always differ from, by individuals. Different individuals will have different line of best fit. And then to get the most reliable line of best fit is to get the equation, to get what we call the regression equation. To get the regression equation, where we need to calculate using our calculator, find the value of our A, find the value of our B, and generate an equation. So with the equation, we can use the equation to extrapolate and interpolate, meaning find values outside the given table we are given, or find values outside the graph, and then interpolate, find values that are not all numbers. We can find all values using the equation. Okay, so now that we did, so now we say now that the closer the points are to this line, the closer the points are to the line of best fit, the stronger the relationship. So you're saying after getting our line of best fit, so we said the points are scattered all around you. The points are all scattered all around you. The points are scattered all around the line of best fit. Okay, our points on the scattered plots is scattered all around the line of best fit. So, but the closer the points are to this line, the stronger the relationship. So the more linear they are, the more compacted they are, the stronger their relationship. And then the more scattered they are, the less the strength of their relationship. Okay, if the points are further away from the line of best fit, the weaker the relationship. So if the line are all around, scattered, around the line of best fit we have created, then we think there's a weak correlation between the two variables. And then we said the two variables must be such that we must have dependent variable and independent variable. And the dependent variable must be plotted on the vertical axis and independent on the horizontal axis. So you have to decide which is dependent on which variable depends on the order to know which will be plotted on which axis. So now to find this, to know how the strength of the relationship between the dependent and independent variable is to check how scattered the points are around the line of best fit. So if the line of best fit slopes to the right, if the line of best fit slopes to the right, that means what? That relationship is positive. If the line of best fit slopes to the right and has a positive gradient, then the linear relationship is positive. So we can have different type of relationship. It can be a positive relationship. It can have a negative relationship. You can have a positive relationship between the two variables, or you can have a negative relationship between the two variables. So when the line of our best fit slopes upwards to the right, if it slopes to the right, it slopes upward to the right, then we say such line has a positive gradient. So it has a positive gradient. And then we said it's a linear relationship. Such a linear relationship, and also it's a positive relationship because what? It slopes upwards because the gradient is positive. And if the line of best fit slopes to the left, when it slopes downwards to the left, when it slopes downwards, then we're saying that it has a negative gradient. It has a negative gradient. So when the line of best fit slopes downwards, then we're saying what? It has a negative gradient. And therefore, there's a negative relationship between the two variables. So when you say positive relationship, what does that mean? It means a directly proportional relationship. A positive relationship implies what? A positive linear relationship implies a directly proportional relationship, which implies that as the dependent variable increases, the independent variable also increases. And as the dependent variable decreases, the independent variable also decreases. So that's the positive relationship. Again, in a positive relationship, a positive linear relationship implies what? A directly proportional relationship. And what does that mean? That as one variable increases, the other also increases. And as one variable decreases, the other also decreases. That's a positive relationship. Okay, like the example we gave yesterday, that's if you want to look at the rate of accidents, and number of cars on the road. So the more bigger the car, the more bigger the road, the more likelihood the chance of accidents. So we think as the number of cars increases, as the more cars and the road get more busy, then the also an increased chances of accidents. So we're saying this will show a positive relationship, a positive linear relationship where your line of best fit is slope upward. And then a negative relationship will imply what? An inversely proportional relationship. So when the relationship is negative, so we're saying is an inversely proportional relationship. What does that mean? It means that as one variable increases, the other decreases. As the dependent variable increases, the independent decrease, or as the dependent decrease, the independent increase. Okay, so that means as one, for example, let's look at if you have a case whereby we have the number of students in the school, and a case of number of students in the school, and then the number of students and the space occupied by the students. So when you have the number of students in a class and the space occupied, the more the number of students that will be fit in the class, the less the space that they will be fitting, the less the space they'll be fitting on. So we're saying such kind of relationship whereby one increase and one decrease as a negative relationship, and then we're saying the line of best fit will slope what? Downwards. Okay, from left to right. All right. Now the gradient of the line of best fit indicates whether the association is positive or negative. However, it should not indicate the strength of the association. So we're saying the slope or the gradient of the line of best fit will tell us if the relationship is positive or the relationship is negative. When it slopes upward, it's positive. When it slopes downward, when it slopes upward, is positive. When it slopes downward, is negative from left to right. So, but that doesn't tell us the slope of the graph will not tell us the strength, how strong this relationship is. What is how strong the relationship between two variables? So to determine the strength of the relationship, to determine the strength of the correlation, between the two variables is to determine our correlation coefficient. To determine our correlation coefficient. Okay, to determine the strength, we want to know what is the strength of the relationship between the two variables. So we think the gradient is not enough, so will not give us enough information on the strength of the relationship between the two variables. right? To determine the strength, what we do, we calculate the correlation coefficient. So R. So with our calculator, we calculate the correlation coefficient. Remember yesterday we talked about the least regression equation. So we explained how to do the least regression equation yesterday, where you need to calculate the value of A. You start with your mode, you press 2, and then you follow the steps. Okay, now I'm finding correlation. One of the important questions we ask in our final exam is finding what? The strength, multiply the correlation coefficient between two variables, and then comment on the strength of the relationship. So we need to know how to find the correlation coefficient of two variables, and also to comment on the strength of the relationship. So the correlation coefficient R is a value that gives an indication of the strength of the association. So your value R, of correlation coefficient, determines the strength of the association. So when it's the bigger it is, the closer it is to 1, the more stronger it is, and the less it is from 1, the weaker it is. It's calculated using a calculator. So to calculate our correlation coefficient, we need our calculator to do that. So let's see how to calculate our correlation coefficient using calculator. Okay. Right. So before we go into calculation of our correlation coefficient, so let's look at the different types of the different strengths of correlation. Right. So we're saying if your scatter point looks like this, if you have the scatter points after plotting your dependent and independent variables, after plotting your values of your dependent, which is on the y, and independent on the x, when you have the scatter point plotted up like this, so what we say, as you can see now, if you look at this pattern, is an increasing pattern. It's increasing. If you're going to draw your line of best fit, it's going to increase from left to right. So we're saying this here is a strong positive linear association. This is a strong positive linear association. Why? The points are not scattered, they are not all over. So the pattern is there. You can easily see the pattern. So you say it is positive. Why is it positive? Because you can see it's sloping upwards. If you're going to draw your line of best fit, it's going to slope upward. That tells you it's what's positive. The gradient to be positive. So you're saying the relationship is positive. The positive relationship is a positive linear association. And also R, the correlation coefficient R will be greater than 0 and very close to 1. So it will be a value very close to 1. So when you have a value very close to 1, then the saying is what? Is positive and is strong. Okay. So there's a strong relationship between the two variables. That means any variable that is plotted, any two variables that is plotted and gives this kind of scatter points, so such variable will be such that they will have a positive relationship, and then there will be a strong relationship between the two variables. Okay, and then if you are to calculate your correlation coefficient R, you're going to get a number that is close to 1. A number greater than 0, meaning a number that is positive and that is close to 1. Okay, and then if we have a scatter point, after plotting a scatter point, and then you have your points like this. So this here, by giving it a critical look, is also a positive relationship. That's a positive relationship, although it is a bit scattered when compared to the first one. So you see here, if you draw your line of best fit, you will see that most of your points will be more scattered around your line of best fit. When you try to draw your line of best fit, try to connect a point. We already said the line of best fit is that line that connects the points in such a way that equal number of points are left on the top and at the bottom. So the line that passes in such a way that equal number of points are top at the bottom is called line of best fit. So when you draw a line of best fit in this situation, you will see that most of the points will be more scattered around the line of best fit. So we're saying that this is it's positive. Why is it positive? Because it's sloping upwards. The line of best fit will slope upwards. But because it's scattered more, then we're saying it's what is weak. We're saying the relationship between the dependent and independent variable is a weak relationship. Okay, if there is a weak relationship here, so moderate positive linear association, your correlation coefficient R will be positive, greater than 0, which is positive, and it's fairly close to 1. It's fairly close to 1. And then we say the weak relationship. So it is positive, meaning as the value of X increases, the value of Y also increases, but the chances of that happening is less. The chance of that happening is less compared to this. Okay, so we're saying that this is a positive relationship because our line of best fit is going to slope upwards from left to right. So that means the gradient will be what? Positive, but the point will be more scattered around the line of best fit. And then that makes it a weak relationship, meaning the chances of both of them increase as the dependent variable increases, the independent variable will also increase, but the chances is less. Okay, right. Okay, now looking at this third one, so this there is a perfectly positive linear association. So in this case, here all the lines are all in place. They are all aligned. All the points are all aligning. So if you are going to draw your line of best fit, then you're going to connect all the points, and then you don't have any points around your line of best fit. All the points are all aligned. So it's saying here, because all the points are all aligned, so it's a perfectly positive. Positive in the sense that is the gradient slopes upward from left to right. So we're saying if you have to calculate with your calculator the coefficient, the correlation coefficient, so you calculate your R will be equals to 1. You got the perfect positive linear relationship, which means as Y increase, X will definitely increase. As X decrease, Y will definitely decrease. Okay, we say this is a perfect positive relationship. Okay, right? So looking at the fourth one, looking at this, so here you will obviously see that there is no obvious pattern in the fourth one. There is no obvious relationship. There's no relationship that's obvious here. So we can be sure if it's going to be increased upwards or it's going to decrease. So there's no obvious relationship here. The points are scattered all over. So here when you say what? There is no correlation. There's no positive correlation. There is no correlation between the X and Y variable. Whatever variable you have on your x-axis, there is no correlation with that on the x-axis. Go on y, there's no correlation with that of x. So if x increases, it does not mean that y will increase. We see there is no correlation, there's no positive correlation, because you can be sure if it's sloping upward or downward, the points are scattered all over. So we're saying there is a 0. Our correlation coefficient R will be equal to 0 when it's calculated with data that is plotted with these scattered points. Okay. So again, let's look at the negative ones now. So if you have a scatter points, a scatter plots that looks like this. So with this, you will see that there's a pattern here. There's a pattern here, and the pattern is such that it's a decreasing pattern. That if you draw your line of best fit, it's going to slope downwards. It's going to slope downwards. So your line of best fit will definitely slope downwards. So here we're saying there's a negative relationship because there'll be negative gradient. The line of best fit, you have a negative gradient. The value of your B in your regression equation will be negative. Remember, you're saying the regression equation is y equals to A, where the A is your intercept on the y-axis, and your B is your gradient, is your slope. In this case, the value of your B will be negative. So because your line of best fit will slope downward. So we're saying therefore that there's a negative relationship, linear association or negative linear relationship between the X and Y variable. And what does that mean in practice? It means as Y increases, there is more likely that X will decrease. And that as well as Y decrease, there's more likelihood that X will increase. What we call what? Inversely proportional. What we call inversely proportional. So this here is a negative relationship. So if you calculate your value of your R, the correlation coefficient, your value R will be negative, it will be close to -1. be close to -1 because it's almost -1, but if you close, because it's not all the points are not aligning, so you won't get -1, but a value close to -1, because around your line of best fit, you still have some line still scattered around, but not far away. Okay, and then the last one, moderate negative relationship association. So this here is still negative, as you can see. You see negative relationship, but it's not strong. It's not strong. There's no strong relationship. There's no strong negative relationship between the y variable and the x variable. Okay, now let's see how this works in practice. Let's see how this works in practice. Right. So this there is perfectly negative association. There is perfectly negative association where it's most definite as y increase, x will decrease. This is an inversely proportional situation. So this one is a perfect relation, perfect negative association, perfect negative relationship. So where our correlation coefficients are equals to -1. And here also there is no correlation. In this situation, there is no correlation because the scatter plot is all over, the points are all over, so there's no definite relationship. There's no definite relationship. The scatter plots are all over, so we say there's no correlation. Okay. All right, so the following table provides different examples of R and how to interpret this. So your R is your correlation coefficient, and what does it interpret? What is the interpretation? So when it's 1, the positive 1, so it tells us it's a perfect positive association. When your correlation coefficient, if you get your R, when you calculate your R as 1, then what does that imply? It implies that there's a perfect positive association, which is a directly proportional, meaning the two variables will both increase at the same time, most likely, and then the two variables will decrease at the same time, most likely. And then if you have values of 0.9, if your R calculated is 0.9, then you see there is strong positive association. You see there is strong positive association. And when you have 0.5, there is a moderate positive association. And then when you have 0.2, 0.2 is now far from 1, but close to 0. 0.2 is not far from 1, but close to 0. So in that case, you say there's a weak positive association, or there's a weak positive relationship between the two variables. And if your R, your correlation coefficient, if you calculate that at 0, then we say there's no association. And then when you get negative 0.2, so we say there's a weak negative association, there's a weak negative relationship. So 0.5 is stronger, it's a moderate negative relationship compared to 0.2. So 0.5, negative 0.5 is a moderate negative association, and negative 0.9 is a strong negative association, and then we have -1 is perfect negative association. Okay. Now let's see an example now. Example, the following table shows information about the age of 8 fossils of a particular species of ape found in South Africa and the interior volume of their skull. When the following table shows information about the age of 8 fossils of a particular species of ape found in South Africa and the interior volume of the skull. So this is the age in millions of years, and then the volume of the skull. Okay, so we have 8 fossils, and then the volume of the skull is recorded. Okay, right. So if you have fossils, fossils are dead remains of animals. So these fossils, 8 fossils, their volume of the skull are recorded, and then they have different sizes. Now, calculate the correlation coefficient R and comment on the strength of their relationship. Calculate the correlation coefficient R and comment on the strength of the linear association. So is there any relationship between the age of the fossils and the volume of their skull? Does the age have to do with the volume of their head? Volume of their skull implies the size of their head. We see some of those old fossils, some of them have a bigger head, some of them, so the size of the head depends, has to do with their, with their age, the age of the fossil. I want to see now, is there any relationship, and how does the relationship exist? What is the relationship between their age, the age of the fossil, and the volume of their skull? So when using this data, so how we go about that? So we try to calculate our R. Try to calculate our R. If you want, you can, first of all, you can plot this on your scatter point. You can plot this on your, plot the scatter point for this data and see what kind of relationship that will show. So you can just do that. You can just get a scatter point, get a scatter plot of these values. Obviously, you can get all the points will not be linear, but all will be scattered. So with that, you can see if there's a pattern or not. So, but if you don't want to do the scatter plots, you can go straight by doing the calculating your correlation coefficient. Okay. So how do you calculate the correlation coefficient? We're saying we use what? Calculator. So how do we go about that? So we're saying a possible calculator program is as follows. So you press mode. So on your calculator, you have the button that says what? Mode. You press the mode and then you press the 2. So when you press the mode, you're going to see a lot of equations. They're going to be shown. We have several equations that will be shown on your calculator when you press the mode. And then you're going to choose 2. You're going to press 2. You're going to choose 2. So 2 implies the one that has it a plus bx. The one that has it a plus bx. All right. And then when you have that, then you now enter your data points. You enter your data points, you try to find the value of your A and B. So, but in this case, you're not finding the value for A and B, you can find the value of R. So we're going to enter it just the way we entered, just the way we did when we are entering, when we are calculating the value of A and B, as we did explain yesterday when you're finding our list regression equation. So we enter your values of X and you enter values of Y. So by the time you press 2 columns will appear. By the time you enter 2, choosing what? A plus bx, then you're going to see 2 columns. So the first column is your X column, the other one is your Y column. So the X column, you enter your dependent variables. Your Y column, for your X column, you enter your independent variable. Yesterday we said the independent variable should go on the X axis and the dependent variable should go on the Y axis. Okay, so for the X column, the 2 X columns that will appear in calculator, you enter all your X values as you have it on the table. So in this case now, which one goes on the X, which one goes on the Y? So X is the independent variable, Y is the dependent. So which depends on which? Which is dependent, which is independent variable here? Does the volume of the score depend on the years, or the years depend on the volume of the score? So what makes sense is the score, the volume of the score will depend on the age in years. Okay, the more the age, the more the volume of the score. So you see the volume of the score depends on their age. Therefore, volume of the score is the independent, the dependent variable. It depends on the year. So the volume of the score is a dependent variable, and then the years in million is independent. Okay, so that means the volume of the score, you're going to enter that on the y-axis, and the years in million will be entered on the x-axis. So meaning values 2,4, 2,0, 0,8, 1,1 will be entered into your x column, which is the independence, which will be entered into, which is seen as the independent variable, and then the volume of the score will be entered into the y column on the calculator. So, and then to do that, after pressing your mode and you choose 2 for equation A plus bx, then 2 columns will appear. So on your F column, you input your independent variable, which is the years, the age in years. So you enter 2,4, you press equals to, 2,0 equals to, 0,8 equals to, 0,1 equals to, 0,6, you enter all your X values. And then you go to your Y values and enter all your Y values as well. After entering one number, you press equals to. Pressing the next number, you press equals to. Pressing the next number, you press equals to. So like that, you enter your X and Y value. Okay, fill in the X and Y column on your calculator. So now what next do you do? Then you now press the AC button. Then you press the AC button. After entering your X and Y column, then you press the AC button on your calculator. So when you do that, then you open up your shifts. You press your shift again. You shift after pressing your shift, and then you press your 1. So then you know show you some other options where you're going to choose 5 for regression, the ROG, which implies what's regression. So in the regression, you will press 3 again. So the 3 again, the 3 will indicate what are. I think the A represents the 1 represent the A, B represents the B. Remember the A we used when calculating our regression equation, and then B, the A and B are used in our regression equation. Well, in this case, we're going to choose R because now we're doing what? The correlation coefficient. So we're going to press 3, which indicates your R, which indicates your correlation coefficient, and press equals to. You choose 3 and press equals to, and then you're going to get the value of the answer will come. So if you do that, enter those values and enter your R and press equals to, then you'll get negative 0.967997673,645. When you do that, you get this answer as your correlation coefficient. Okay, that is the correlation coefficient of the two variables. This is how the two variables are related. This is their correlation coefficient. Okay, then to restore the calculator back to the normal mode, then you can press what? You can press 1, you can press mode and then 1 to get the calculator back to the normal mode. So basically our R is calculated as gotten as 0.9679973,645. That's our correlation coefficient R. Now, to now comment on the type of relationship between them now. So negative 0.96 is a value very close to negative 1. The value very close to negative 1. Being negative implies that what is a negative linear relationship? Is a negative what? Linear relationship, which means that as the years, as the age increases, the volume of the score what decreases. Which as the age increases, the volume of their score decreases, or as the volume of their score decreases, the age increases. So that is the meaning of the negative value. So it's a negative relationship, meaning as one value increases, as the dependent variable increases, the independent decreases. That's the implication of the negative sign. And then looking at the value, a value very close to 1. So a value close to negative 1. So that implies that it is almost perfect. It is almost is a very strong negative, is a very strong negative linear relationship because it's very close to 1. So to comment on that, is saying therefore there's a strong negative linear association between the two variables, meaning as the age increases, there is most likely that the size of the score will decrease as the gut age, as the forces get what increase, as the age of the forces increase, the size of the score decreases. So that is the implication of that. The meaning of our correlation coefficient variable. Okay. So now and then if you plot if you plot your values on a graph, you're going to have scatter plot that looks like this. If you try to plot the values, plotting your volume of score on the vertical axis and plotting your age on the horizontal axis, as I said, volume is your y-axis, is a dependent variable which must go on the y, and your age is the independent variable which must go on the x. So when you plot that using those values, you're going to get a scatter point that looks like exactly like this. So with this here, you can see that the points are not straight, they're not all aligning, but not far from your line of best fit. They are not aligning, but they are not far from your line of best fit. So, but if you look at the gradient, because it's decreasing, the line of best fit does what decrease from left to right. So we're saying it's at a negative gradient. It is a negative gradient, and then there's what? It is negative relationship between them, and then because the points are not far from your line of best fit, then there's a strong relationship between the volume of the score and their age. As the volume of score increases, the age decreases. As the age increases, the volume of the score decreases. Okay. So this is an example we can also examine during the Gauteng winter months. During the Gauteng winter month of July, number of patients visited the local hospital suffering from influenza. The table below shows the number of patients treated. So this is the number of patients treated for influenza and their dates. Okay, date of the month and number of patients treated. On the 4th of July, 360 were treated, 30 patients were treated. On the 5th of July, 280 were treated. And then on the 10th of July, 380 were treated. So like that. As you know, July is a winter month, which means that most people, there will be increased number of people who will be having flu, influenza. So we want to check now, is there any correlation between the dates, or as the date increases, does that imply that the number of influenza people, number of cases of influenza will increase? Is there any relationship between the dates and the cases of influenza virus that people had? So we want to see if there's a relationship between that. So and to do that, what you do, draw a scatter plot, draw a scatter plot with the above data, plot all this on your scatter plot, then determine the equation of line of best fit, which is y equals to a plus b x, and then draw a line of best fit, then estimate, using your equation, estimate the patient that were treated at 28. How many patients were treated at 28th of June? So from your graph, you can check how many patients were treated at 28th of June. So go by 28th of June and go on the side of the date and see, go on the side of the date, which is on 28th, and see how many patients, trade it down on the number of patients and find out how much you have if you want to use the graph. As well, you can use the equation by substituting 28 into the equation. Then you can also find, your list equation, list regression equation. So you can also find the value of patient that we treated on the 28th of July, because the thing, the number of patients to be dependent on the date. The number of patients to be dependent on the date. Okay, and therefore the date will be on your x-axis, the number of patients be on the y-axis. So we will end the class for today here, and the next class we continue with probability and probability and counting principle. So thank you for attending and enjoy the rest of your day.
Hello.